Okay, so the next thing my buddy Steve's going up on my bench here is a Soundcraftsmen MA5002 stereo power amp. This thing's not working at all. It does power up, but it's going through a rhythmic power cycle, indicating that it's probably firing into a short. So we're going to pop that up there and take a look at it and see where the problem lies. Spoiler alert, I'm actually doing this after I worked on it, and I try a troubleshooting technique that theoretically should work, but there's always a but you'll see as you watch the video. Alright, I've got the cover off of this thing, and I don't see any wires loose or boards flapping in the breeze, so it should be okay to fire up. We'll see what we get when we do. So I'm not sure how well you can see or hear this, but every few seconds there's a small thump or click and the lights flash. Something is either loading down the power supply or there's something wrong with the power supply. This has a very sophisticated power supply system, and I'll translate that for you. That means I don't understand how it works. But we're going to take a look at this and see if we have a problem either in the power supply or if something is loading it down, which would also give you that kind of symptom. Alright, so the kind of power cycling this thing was doing, where it was clicking and you see the lights flash, are indicative of a power supply that's firing up into a short and can't come up, and the cycle just repeats itself. Switch mode power supplies do this. You may have heard of something called tick-tick mode, where they make a ticking sound as they try to come up, but there's a short. So I want to take a quick look at the output stages to see if there's a problem there. Easiest way for me to do this is I'm just going to connect one lead of my meter to the positive output and just look at one of the collectors, see if I have a short. Okay, I don't see a short here, don't see a short here. So look at the other channel and look at one of the collectors, and yeah, we've got shorted outputs. So we're gonna have to look at this channel, see what happened. One good thing about a power supply like this is once it encounters a short, it won't go up to full power. What's so destructive about shorted output transistors is they can cascade back, and it takes a long time for a fuse to blow. I mean, it looks like it goes in the blink of an eye, but in electronic terms, it's a fairly slow process. Protected power supplies like this, or crowbar supplies, prevent further damage. And the general failure mode of output transistors is a dead short. That's why I decided to give this a quick check. And even though I can get to most of the terminals on these, it's just easiest to go to the output and just see if you're shorted emitter to collector. And we got some emitter collector shorts over here. So I'm going to have to disassemble this and see what it's going to take to get to the outputs, and we'll take it from there. Okay, so I got the first four pulled off the heatsink assembly. They were the easiest ones to get to. In order to get to the ones here, I'm going to have to lift this board and hope I have enough slack to swing it out of the way so I can get the screws out to pull these to check them. But anyway, I have the first four here. These are the NPNs, and if we check them base to emitter, and before I do that, I don't have the meter where you can see it. Let's see if this will work. If I swing it up a little, you should be able to see that. This meter will chirp if you have a good junction and beep continuously if you have a short. I erroneously believed that as long as it chirped, it was okay, but you do have to kind of keep an eye on the meter, because I've had some leaking components that would chirp but still weren't good. But we should get like between 0.4, 0.45, 0.5 something. When we check a good junction on an output, we get 0.59. That's a good junction. That is base to emitter, base to collector, looks good. And when we check emitter to collector, in one direction we get conduction, but it looks like 0.445. So this transistor may have a flyback diode in it, It's just marked 26. On the schematic, it tells you what a industry standard part number would be for that. These other ones, I can't really read. That might say 22, 24, or Z something. I don't know. But anyway, we checked this one. That looks good. Base to emitter. Base to collector, good. Emitter to collector. Emitter to collector looks good. This one, base to emitter, good. Base to collector, good. Collector to emitter, dead short. This one is definitely bad. Base to emitter, good. Base to collector, good. Emitter to collector, good. So we have one shorted transistor here. Rule of thumb is you replace them all if you find a short. I've talked to the owner, see how far he wants to go with this. You can replace the bad one. It may work for a while, may work forever, may blow up the next time you turn it on. You don't know what kind of stressors were put on these during the short. So I'm going to have to pull these and check them, but we have found one bad one already. Okay, so I made an assumption when I was diagnosing this, when I put one lead at positive speaker output and tapped the collectors of each of these transistors, and that assumption was that this was a full complementary output design. And I want to talk briefly about what the differences are. A full complementary output stage has NPN and PNP transistors. The NPN outputs and drivers will all be tied to the positive supply, and the PNP will be tied to the negative supply. Now, in earlier solid state amps, they weren't able to consistently manufacture high current, higher voltage PNP output transistors. So they did what they called quasi-complementary or complementary, which is where you had all NPN outputs and your drivers would be NPN and PNP. And I'm going to show you here what a full complementary output stage looks like. You can see that the testing methodology I used would have been okay here. Maybe not on the drivers themselves, but certainly on the outputs where I was looking for trouble. But on this one, you can see that the collectors on the negative going side of the amplifier are tied directly to the speaker output. So that's always going to look like a dead short because it is a dead short. That's by design. But every once in a while the audio gods throw you a bone, and I was able to see clearly that there was a short on the positive going side. So the methodology worked as far as it went. I just hadn't looked at the schematic when I did that. However, it did point out where we had a problem, and I found a shorted transistor on the positive going side and a shorted transistor on the negative going side. And I still have one more to pull out of here and check. These are a bit of a bear to get to. These aren't too bad. You just drop the back. You can get these out, but these are a little more involved. I had to pull this driver board up here, looks like this one, so I could get to the screws, and they're still not easy to get to. But I got one more I got to pull out and check. Like I said, so far I found a shorted one here, shorted one here. And I'm going to re-grease and replace the mics on these, and I don't know I'm going to replace all the transistors. I still have to talk to the owner about that. But something else that came up while I was testing them is that this is one of the drivers. You can see it has a 26 stamped on it. And the schematic shows us that this is a 2N6285, I think. I don't have it in front of me, so I'm kind of winging it here. And when I looked that up, it says that it is a Darlington transistor, but these don't check like any Darlingtons I had seen. What these check like is a regular transistor with a flyback diode. And I'll show you what I mean by that. See if we can get the meter in here. In fact, I'm just going to stop this right now and go back when I've got it set up. Okay, so if we check this transistor, we get 0.6 between base and emitter. We get about 0.56 between base and collector. And then when we check the emitter to collector, we get about a diode drop in one direction. So it looks like there's a flyback diode there. And if you look at the representation that I found on the data sheet, you'll see that it is in fact a Darlington transistor. I was expecting to see 2 diode drops between the base and emitter, which is what you get, because remember, you're checking through a base whose emitter is tied to the base of the next transistor, and then you're checking that emitter. So you should get 1.2 volts. And you can see clearly I'm not. But there are resistors in there, and that's why I'm reading what I'm reading. So this transistor checks good. It just kind of threw me because it doesn't look like a Darlington, but apparently it is. Okay, well, I got this thing back together, and what I did is I pulled these 2 shorted transistors out. This was all I found wrong. I checked the emitter resistors as well as I could. Everything is really hard to get to because of the way this thing is constructed, but everything I could get to checked out okay. So I brought it up on the variac, and I'll show you what that looked like. They say in the service literature that if you start it really low in the variac, you have to feed the external 12-volt supply in to turn the power supply on. But I started out around 60 or 70 volts. Didn't see any smoke or flames, so I slowly ramped it up, and it looks like it's okay now. It's not power cycling like it was. So I turn it on. It's just barely a glow here. And I ramp the voltage up. See the meters start to glow a little more brightly. Okay, so I'm going to get it up about 120. We're pulling a little over half an amp. I'd say that's good. And let's take a look at the test equipment and see what we got up here. I'm going to zoom in a little. Okay. Feed some signal in. Oh yeah. Okay, so that's about 5 watts. Let's feed a little more in. It's supposed to be 250 watts a channel. It's 22. Everything looks happy so far. I should check the bias. God knows where the adjustments are, but knowing this thing, they're hard to get to. All right, before I run it up too much higher, I'm going to see if I can get the bias set on this thing. Even though I don't know what it's supposed to be set to, I'm just going to set it to about 25 milliamps should be good. Okay, so I've got this thing, set the bias. There's a procedure in the service literature, uses a distortion analyzer. I'm not a big fan of that. It's too easy to set the bias too high. I find it's much more accurate to just measure across one of the emitter resistors and just set it that way. I'm always more comfortable with that. And got it set, and this thing's putting out pretty good. Let's see here. So we are putting out, let me get it out of clipping. Yeah, it's supposed to be what, 250 watts a channel. It's doing pretty good. Right on the edge there, but the power's sagging. I'm down to 113 volts. If I crank the variac up a little bit, we get a little more output. So yeah, this thing's looking pretty good. The only thing that's kind of weird is the meters are stuck high. I'm not sure what's going on with that. You might have noticed that one of them was not zeroed, the one on the right, which is where we had our problems. But if you look now, what is going on here? You can see they're both kind of stuck high, and there's no input at the moment. So I'm going to have to look at the metering circuit, but at least the amplifier is now working. Alright, so I wasn't paying that much attention to the meters. This one was all the way down like this, but they have mechanical issues. I'm going to have to pull the front off. Looks like it's going to be a pain. This whole thing was like a ship in a bottle. I don't know how they put it together. It's probably not that bad to put together, but it's a bear to service. In any event, these meters are sticking. So if you put signal in, it'll go up, but it won't. It'll go all the way back down. The right one is really stuck. It was like that. So I don't know if the faces come loose and is pressing against the needle. I don't think so, at least from the angle I see here. So I'm gonna have to take it apart. This is really delicate work and I'm really not good at that. I'm gonna at least have to take a look. I may let the owner take care of it because he does service things. He just gets, he's learning and he gets stuck at certain points and just brings the stuff to me. All right, so I've gotten the meters out, which necessitated pulling the top, bottom, and both sides so you can take the rack handles off and get the front. It's, this thing was built, everything was built around everything else, so it's really a bear to get to. But the meters look like, at this point, this amp had a hard life. Steve told me this himself. And there's a good chance that it took a hard mechanical shock. Here's a picture of one of them. You can see it's kind of corroded. The metal looks like it's kind of corroded inside. And what has happened is that the armatures or the motor assembly of the meter itself has broken away from the needle assembly. These are a very delicate balance. They're kind of like a voice coil on a speaker. It's got to ride just right, not rub against anything, so that it can rotate, the armature can rotate around the magnet and therefore swing the needle. And it looks like they've both gotten detached. I don't know if they were exposed to extreme temperature and the bonding agent, whatever glue they used, just gave up the ghost. Could have been after so many years, but I believe it was a pretty good mechanical shop. There's no bent cooling fins on the back or dents in the case, but it doesn't take a lot. These things are very delicate. So I'm not going to be able to do anything with these meters. Steve said he had some that he might be able to retrofit into it. You could just take the faces off, have the Soundcraftsmen logo and scale and put them in, as long as the movement is the correct movement. But anyhow, that's all we can do with this. And I'm going to have to say goodbye. It's at least passing audio now. And I'm going to sign this off. And as always, I thank everyone for watching. And I like giving back to the community. That's given me so much. Thanks a lot.